Welcome to MySci Unit 19, Sensing Tsunamis. This is a 4th grade physical science, earth science, and engineering unit where students explore how tsunamis form, why they are dangerous, and how people can use technology to detect and warn others about tsunamis. This 4th grade unit completely covers 2 physical science, 2 earth science, and 2 of the 3rd to 5th grade engineering standards. It partially addresses 1 life science and another physical science standard. All but one of the next generation science standards correspond to a Missouri Learning Standard listed in parentheses on this chart. If you'd like, take a moment to pause the video and review them. This unit is divided into 2 sections. Each section has a driving question designed to reflect what we anticipate students would naturally ask through their learning process. Section 1 includes 3 lessons. Introducing the anchoring problem happens during the Engage portion of Lesson 1. Section 2 includes 4 lessons. Overall, the unit should take about 29 to 34 days to complete. The anchoring problem is tsunamis can be very dangerous to people. Students will explore where in the world tsunamis occur, how and why they form, and then consider ways people can communicate tsunami warnings over long distances. Students will work in engineering teams to design a tsunami detection and warning system using computer coding and a microbit device. The driving question for Section 1 is how do tsunamis happen? Students connect to the anchoring problem by participating in a read-aloud about a tsunami that comes to a village. Students will look for Earth features on a globe. They will use ArcGIS, an online map, to locate mountain ranges, earthquakes, volcanoes, and tsunamis to identify patterns among their locations. Students will then use slinkies to explore how waves are formed and investigate patterns of wave structure and energy transfer. The section concludes as students investigate how energy transfers into water and causes tsunami waves using a water tank model. Through the storyline in Section 1, students gain an understanding of these standards-based big ideas. Maps can be used to locate patterns in Earth's features. Major mountain ranges, earthquakes, volcanoes, and ocean structures occur in patterns. Tsunamis happen in oceans near where earthquakes and volcanic eruptions happen. Tsunamis are large waves. Waves are formed by a disturbance that transfers energy through a material. Waves occur in patterns of similar structures. Waves have an amplitude and wavelength. When an earthquake or volcanic eruption causes a displacement of water, energy is transferred, making a tsunami wave. The motion of water changes in the deep ocean compared to at the shore. Section 1 should take 11 to 14 days to complete. The driving question for Section 2 is how can we protect people from tsunamis? In this section, students connect to the anchoring problem by considering how people can be protected from tsunamis. Students first consider if humans could detect a tsunami using their senses by making observations about what frequencies of sound humans can hear. Students compare human senses to technological sensors and animal senses. Students then construct circuits to learn how energy transfers. They learn about Morse code and design a way to communicate over long distances using signals or codes. Students then use Scratch, a kid-friendly computer coding language, to explore the transmission of digitized information. In engineering teams, students use a device called a microbit along with Scratch to develop and test a tsunami warning system using computer coding that sends messages over long distances. Students compare designs with each other, taking into account the criteria and constraints. The section concludes as students compare designs with each other, sharing feedback. Teams finalize their designs and share them with the class. We'd love to hear about the experiences your students had as computer coders. Through the storyline of Section 2, students gain an understanding of these standards-based big ideas. Sound has energy. Humans can detect sounds from the environment. The information from the sound is processed in the brain, and using memories initiates a response. Humans cannot use their ears to detect tsunamis before they arrive, but it might be possible for devices to be used which can. Information can be communicated over long distances by transferring energy through electrical currents. Computers can be coded to digitize and decode information and send it long distances without it being degraded. We can design a tsunami message using sensors and computer programming that is easy for people to understand and can quickly be sent over a long distance. Section 2 should take about 20 days to complete. Our team here at MySci hopes you and your students enjoy sensing tsunamis and becoming computer coders. We look forward to your feedback. Happy MySciencing!